Lesson 7-5, solving equations with variables on each side. And in this lesson, you learn to solve equations with a variable on each side. Why is it important? Because you can use equations to determine when two city populations will be the same. So let's take a look at this concept, and let's take a look at this formula. The formula F equals 9/5 C plus 32 is used for finding the Fahrenheit temperature when a Celsius temperature is known. When the temperature is the same on both scales, F equals C. So basically what it's saying is that to be able to find the temperature in Fahrenheit, if Celsius is given, just follow this formula. Okay? So replacing F with C results in the equation C equals 9/5 C plus 32. Okay? So when the temperature is the same on both scales, we know that the F is equal to C, and that's the reason why in this case, okay, assuming that they're equal, we simply substitute F with C, so C equals 9/5 C plus 32. Okay, so in C equals 9/5 C plus 32, the variable is on each side of the equal sign. Use the properties of equality to eliminate the variable from one side, then solve the equation. So what it's saying is that if you have a variable on both sides, first thing you need to do is decide for yourself what variable you want to undo, okay, left or right. It's up to you. It doesn't matter. You'll end up with the same answer. So we need to undo one of the variables, okay, and in this case we want to undo negative 5/6 C. We want to undo that C. Why? Because again, the objective of the lesson, or sorry, the objective of solving an equation is to isolate C on one side of the equation, and in this case, if you look closely, C is already isolated. So all we need to do is get rid of this C, or undo that C, to be able to solve for our C. Okay? So what do? We subtract both sides. First, copy the problem, and then we subtract 9/5 C from each side of the equation. So C minus 9/5 C will give you 5 over 5, which is remember that C will always have a coefficient of 1, and we simply renamed 1 as 5 over 5C. Why 5 over 5C? Because it's going to be easier for us to subtract these two fractions because they now have like denominators. Okay? So 5 over 5C minus 9/5 C will give you negative 4/5 C equals 32. And now we want to solve for C, meaning we need to undo negative 4/5. And remember that is a multiplication operation. And for us to be able to undo negative 4/5 C, we need to multiply both sides by the reciprocal of negative 4/5 C, or negative 5 over 4. And that'll simply bring us C, okay? And since you multiplied the negative 5 over 4 to the left side, we need to do that to the other side, and we end up with the value of C equals negative 40. Okay? And that is C equals negative 40. Checking our answer, we simply substitute the value of C to both C's in this equation, okay, and see if they become equal, and we end up that we soon find out that they're both equal. Okay, so negative 40 equals negative 40. Okay, so what it's saying is that when F is equal to C, in this case, when the temperature is the same on both scales, that would be at 40. Let's take a look at example number 1. Solve 7n plus 12 equals 2.5n minus 2. Okay, again, we have variables on both sides of the equation, and we want to undo one of them to be able to simply solve for n. Okay, and look closely. You can either do negative 7n or 2.5n. It's actually up to you. let's see how the uh, book does it, and then we'll do it ourselves as well and eliminate the other one. So in this case, the book decided to get rid of undo 2.5n by subtracting 2.5n to both sides. Now the reason for this is because once you subtract 2.5n to both sides, you still end up with a positive, okay, coefficient of n, okay, which will give you less steps in solving for n. So when you do that, you end up with 4.5n plus 12, okay. Oops, I forgot that step. 4.5n plus 12 equals negative 2. And then now you need to undo positive 12 by subtracting 12 to both sides. So you end up with, 4.5n equals negative 14. And then we need to undo 4.5n by dividing both sides by 4.5. We end up with the value of n as negative 3.1111, okay, using a calculator. So the value of n is negative 3.1, bar notation on 1. Okay, let's take a look at how to solve this if we undo 7n. Okay, and then let me do this on this side right here. Let me make line thinner. So it's okay. So you have 7n. I'm going to recopy the problem. Well, actually, I'm going to put it down here because we have space. Okay. So recopying the problem, 7n, okay, plus 12 equals 2.5n minus 2. So in method 1, okay, we got rid of, or we undid 2.5n by subtracting both sides by 2.5n. So in this case, we will now undo 7n. So in order to undo 7n, we simply subtract 7n to both sides. Okay, and if you subtract 7n to both sides, okay, you end up with 12, okay, because that'll be 0, equals negative 4.5n minus 2. Okay, so now we want to isolate this n. So what do? We add 2 to undo negative 2 to both sides of our equation. And we end up with 10 equals negative, sorry, not 10. What am I doing? 14. Okay, so this now becomes 14 equals negative 4.5n. Okay, and then since we want to solve for n, we simply divide both sides by negative 4.5. So we divide both sides by negative 4.5, and if you notice, okay, a positive divided by a negative will still be a negative, and we still get the same answer. Okay, so n will be equal to negative 3.1, bar notation on 1. So it's the same. So it doesn't really matter which variable you want to get rid of. Okay, it's all up to you. Okay, let's take a look at example number 2. Example number 2, sometimes a rectangle is described in terms of only one of its dimensions. Remember the dimensions of a rectangle, length and width. Okay, to find the dimensions, you will have to solve an equation that contains grouping symbols. When solving equations of this type, first use the distributive property to remove the grouping symbols. Okay, so how do we do that? Let's take a look at this example. The perimeter of a rectangle is 74 inches. Find the dimensions if the length is 7 inches greater than twice its width. Okay, again, find the dimensions if the length is 7 inches greater than twice its width. So what do we know? First, let's represent, okay, the variable. So let W represent the width in inches. Then 2W plus 7 represents the length in inches. Why is that? Because it's saying that the length is 7 inches greater, which is plus 7, than twice its width, which is 2W. Okay? So remember that the formula for perimeter of a rectangle is 2W plus 2L equals P. And this is how our rectangle will look like. That's our width. And that is the length value. Or sorry, that's how we represent our length in this rectangle. Okay? And then using the formula, okay, 2L plus 2W equals P. We substitute W and L. Remember, W is still W, so it remains the same, but L is 2L plus, sorry, the length is 2W plus 7, so we end up with 2W plus 2 times the length, which is 2W plus 7 equals 74. Then we use the distributive property. We distribute 2 to 2W, and we distribute 2 to 7. End up with 2W equals, okay, 4W plus 14 equals 74. And then before we even solve for the variable, we need to simplify the expression. 2W plus 4W plus 14 will give you 6W plus 14 equals 74. Now we have a two-step equation that we can work with. First, we need to undo positive 14 by subtracting 14 to both sides. Okay, we have 6W plus 14 minus 14 equals 74 minus 14. And that leaves us with 6W equals 60. And then since 6W is a multiplication operation, we divide both sides by 6. So we have now 6W equals 10. So the width is equal to 10. But we're not done because it's asking for the dimensions. We only found the width. So how do we find the length? Okay, so since the width is 10 inches, we now can evaluate 2W plus 7. Remember our let statement. Our length represents 2W plus 7. So we simply substitute 10 to W. And after doing that, we have now 2 times 10 plus 7, or 27. So the length is 27 inches. Okay? Now to be able to find out if our answer is correct or not, we simply substitute 27 and 10 to 2W plus 2L. And you'll find out that the perimeter will be 74 inches. Okay, so basically this is what you do. Remember, this is our width and this is our length. So to be able to, if you want to check your answer, you now have to do 2 times 10 plus 2 times 27. Will it be equal to 74? Okay, and this will be 20 plus 54 equal to 74. Of course, sorry, I get 75. Okay, so equal to 74, and we've checked our answer. There you go. Okay, before we continue with the next example, the secret word for this particular lesson would be parallelogram. Spell it right. Secret word is parallelogram. Okay, let's take a look at this one. Some equations may have no solution. The solution set is the null or empty set. It is shown by the symbol, 2 brackets, nothing inside, or simply a circle with a line across it. Other equations may always be true and have every number in their solution set. So these are 2 equations which will give you a no solution, okay, a null set or an empty set, or an equation with infinitely many solutions. Let's take a look at letter A. 2x plus 5 equals 2x minus 3. Let's copy the problem and solve for the variable x. We need to undo one of the variables. Okay, it doesn't matter because they're both 2x. We subtract 2x to both sides. And if you subtract 2x to both sides, you end up with 5 equals 3. And if you notice, 5 will never be equal to 3. So, in this case, since the sentence will never be true, the solution is a null set. Okay? Take a look at the next example. You have 3x, 3 times the quantity x plus 1 minus 5 equals 3x minus 2. Okay, first things first, we need to simplify this equation. Sorry, this expression by getting rid of the parentheses. So we use the distributive property. Okay, using the distributive property, Well, they added 2 to both sides. Okay, before they use the distributive properties, you add 2 to both sides, you end up with 3 times the quantity x plus 1 minus 3 equals 3x. Okay, and then you use the distributive property, you now have 3x plus 3 minus 3 equals 3x, and you end up with 3x equals 3, and 3x equals 3, okay, will always be equal, the same any time. So basically, to be able to solve for x, we divide both sides by 3, end up with x equals x. When you end up with this type of an equation, okay, the sentence will always be true. So that means any number that you substitute to x will make this equation true every single time. So that means the solution set will be all numbers. What I said in the beginning was that we use a distributive property, so we can do this too. You can use the distributive property. Let me copy that first. Minus 5 was 3x minus 2. So using the distributive property, let's make this thinner. Okay, so this becomes 3x plus 3 minus 5 equals 3x minus 2. Simplifying this whole thing, you have 3x minus 2 equals 3x minus 2. Here alone, you know right away that they're equal to each other. Whatever you do, you'll still end up with the same answer as x equals x. So the solution will be all real numbers. Okay? So any number that you substitute for x will make this equation true. Okay? And that's the end of our lesson, boys and girls. Thank you for watching.